Okay, this is example 7, and here we have an initial value problem, right? We have our second order linear equation, but we're given initial conditions. So here we're going to find the general solution, but then we're going to find the specific coefficients, C1 and C2, because we're given the initial conditions, so we'll be able to find a particular solution. So the nice thing is, well, we just start finding the general solution as we have been doing. So let's do, so in honor of Valentine's Day is coming up on Saturday. I'm going to use pink. So characteristic equation, okay, is going to be r squared, right? I'm looking at this guy, plus 2r. No, well, plus y, but there we don't have a derivative. So that's just going to be plus 1, right, because our coefficient is still 1 in front of y, equals 0. Okay, there's our characteristic equation. It's just a quadratic equation. If you factor this guy, you will get r times r is r squared. 1 times 1 is 1. 1 plus 1 is obviously 2. So, I mean, they're the factors, but notice they're repeated factors. So we can, well, we can say again, doesn't matter which one you use, but r is equal to -1, or r1 is equal to -2, which is really equal to r2. So they're the same, right? We get a double root, double, right, or sometimes, but this book uses repeated root. Okay, so what is our general solution? And, well, for purple, so our general solution, okay, that's going to be my y of x. Okay, what's the form? I know I'm going to use theorem 6. So y of x is, okay, C1, let me write this again, C1 plus C2x times e to the r1x. And again, if you distribute this guy right in here, like we did last time, you'll get that factor of x in. So we have, equals, okay, well, I'll just write, I want white, C1 plus C2x, e to the, my r is -1, or just -x is fine. Again, I'm going to distribute because this is going to be very helpful in finding the particular solution. So we have C1 e to the -x plus C2x e to the -x. Again, I need that factor of x because these two terms, right, or functions have to be linearly independent of each other, right? They can't be dependent of each other in order for this to work. Okay, so here's our, okay, so here is our general solution, right? Because we don't know what C1 and C2 are, but they did give us initial conditions, so I'm going to use these guys now. Let's see, let's pick a different color. Let's do blue. Okay, so now I'm going to use my initial conditions. So use these guys to find your C1 and C2, right? So these guys. Okay, so all we have to do is, well, we know what y1 is, so we can definitely find y prime and y double prime, so differentiating, well, that's just a constant, so we keep that. The derivative of e to the -x is e to the -x times -1. So I'm just going to go ahead and put that negative out there. And then we have, the derivative of the next term. So that's going to be, well, we're actually going to use the product rule. So after you use the product rule here, so I'm going to write plus C2, and then once you use the product rule, I'm just going to go ahead and write it out. You should be able to do this part on your own. E to the negative x minus C2x e to the negative x. So again, how did I get this guy? Right, use product rule. And maybe, let's see, it's too green. So there's my product of functions. So I'm going to use the product rule. And that's how I ended up with that guy. Okay, so I found my first derivative. I'm not finding my second derivative because my initial conditions, right, they don't involve the second derivative. I have y of 0 is equal to this, and then I have y prime of 0 is equal to this, right? This represents a slope, and that's an actual specific point, the y-intercept on the graph. Okay, so y of 0 is equal to 5. So I'm going to write that down just so I don't have to keep moving back up. So y of 0 is 5, and y prime of 0 equals -3. And make this a little bit bigger. Okay. So y of 0 is 5. Well, I have y of x right here, so y of 0, well, that means that I'm just going to insert 0 for every x here. So that's going to be, C1 e to the, -0 or 0 plus C2 times, well, this is great, 0 times e to the -0 again, or 0. But I know that's equal to 5, right, because it's given right there. And I'm going to go ahead and write, well, let's just go ahead and do this part. Okay, this is a big 1, right? E to the 0, this is a 1, but it doesn't matter because anything times 0 is gone. So I'm left with, actually I'm left with, let's be careful with this. I have C1, I guess, plus 0 equals 5. Okay, so I found C1 already. It's 5. C1 is equal to 5. But I want to find C2. Well, that's where y prime comes in. So there's my y prime. And y prime of, okay, so I have x, but I'm given y prime of 0. So I have y prime of 0 equals, and then again, I'm going to insert 0 to all my x's here. So C1 e to the -0 or 0 plus C2 e to the 0. And this is great because minus C2 times, well, this is all going to be 0 because, my 0 is right there. So that's going to be gone. And remember, this guy is what, equal to -3. Okay, so we have, well, this is a 1, so C1 plus C2, that's gone, equals -3. But I already know what C1 is. C1 is 5, so 5 plus C2 is -3, and this is just a simple algebraic equation, right? Subtract 5 from both sides. And actually, I think I'm supposed to get I think I'm missing a negative. Yes, I am. Okay, so I'm going to zoom in here. And, okay, do it in pink here. I forgot this negative, right? So that negative, I forgot to bring it down right there, so that means it's right there, so it's right there. Okay, so now we have, well, -5 plus C2 equals -3, so now C2, if I add 5 to both sides, then I get my 2. And now we can rewrite, right, our solution, our particular solution, because we found our C1 and C2. So we have y of x, right, so our desired particular solution. Well, it was C1, but my C1 is 5, so that's 5e to the -x plus C2, but C2 is 2, and then times again that factor of x, because they have to be linearly independent, times e to the -x. So here is my particular, right, or unique solution, right, because I know my C1 and C2, it's not general. So hopefully it wasn't too bad. I know it's a little bit long, but again, the main idea here, you're going to be factoring, some form of factoring. Okay, the two main steps here is find your general solution to solve an initial value problem. Step 1 is find the general solution, and then after you find the general solution, right, you're going to use your initial conditions to help you find your C1 and C2, and I mean, you're going to have a nice, little system of equations. Sometimes it might be easy, sometimes you might have 3 equations. It's not that bad. I mean, you guys know how to solve matrices, so we'll review it. I promise we'll review that. Okay, so that's one of the initial value problems, and I'll do another one in the next video.